Hello dear student, in this particular video we are going to learn sensitivity of a galvanometer. So sensitivity of a galvanometer is defined as a galvanometer basically said to be sensitive if it shows a large scale deflection even when a small current is passed through it or a small amount of voltage is applied across it. Basically, the sensitivity of a galvanometer means that when we pass current or we apply voltage across the galvanometer coil, then amount of deflection produced in the galvanometer per unit current or per unit voltage, that we call the sensitivity of a galvanometer. And based on current and voltage, we say current sensitivity and voltage sensitivity. So there are two more terms. One we call current sensitivity. So what is current sensitivity? Deflection per unit current, and this is denoted by I subscript S. We know alpha value, so alpha by I will be equal to NBA by K, and this term we call current sensitivity. And how do we define? It is defined as the deflection produced in the galvanometer the deflection produced in the galvanometer when a unit current flows through it. Unit current means per unit current, okay? Alpha upon I is called current sensitivity. Next is voltage sensitivity. So deflection per unit voltage is called voltage sensitivity. So we know alpha and voltage we can write I into R, and alpha by I we know NBA by K. So if you want to develop the relation between voltage sensitivity and current sensitivity, Vs is equal to NBA by K is nothing but current sensitivity upon R. So Vs is equal to Is upon R. And how do we define voltage sensitivity? Deflection in the galvanometer per unit potential difference applied across its end. The deflection produced in the galvanometer when a unit potential difference is applied across its ends. So now we are going to discuss about factors on which the sensitivity of a moving coil galvanometer depends. Factors on which the sensitivity of a moving coil galvanometer depends. First one is number of turns in the coil. Number of turns in the coil. Second one, magnetic field. Third one is area of the coil. And fourth one is the spring constant or torsional constant of the spring. Torsion constant of spring. That is K. So बच्चों, these four factors are very important. यह आपको एग्जाम में लिखने के लिए आता है. जैसे जैसे आप नंबर ऑफ टर्न्स आप बढ़ाएंगे, ऑब्वियस सी बात है, सेंसिटिविटी ऑफ द गैल्वेनोमीटर क्या होगा, बढ़ेगा. एक बार यहाँ पे थोड़ा सा हम लोग इसको डिस्कस करते हैं. सेंसिटिविटी जो हमने डिफाइन किया है, करंट सेंसिटिविटी या वोल्टेज सेंसिटिविटी, इसको लिखते हैं. इट इज एन बी ए बाय के. दिस इज करंट सेंसिटिविटी. और वोल्टेज सेंसिटिविटी इज एन बी ए अपॉन के इंटू आर, रेजिस्टेंस ऑफ द कॉइल. सो अगर यहाँ पे नंबर ऑफ टर्न्स बढ़ाएंगे तो करंट सेंसिटिविटी बढ़ेगा, डायरेक्टली प्रोपोर्शनल है. मैग्नेटिक फील्ड को भी अगर बढ़ाएंगे तो दोनों करंट और वोल्टेज सेंसिटिविटी बढ़ेगा. एरिया ऑफ द कॉइल अगर बढ़ेगा तो अगेन दिस इज गोइंग टू इंक्रीज, दिस इज आल्सो गोइंग टू इंक्रीज. करंट एंड वोल्टेज सेंसिटिविटी बोथ विल इंक्रीज. और ये जो है वो के इनवर्सली प्रोपोर्शनल है. तो अगर इसको आप बढ़ाएंगे तो दिस विल डिक्रीज. करंट एंड वोल्टेज सेंसिटिविटी बोथ विल डिक्रीज. So in this way we can comment on the factors on which the sensitivity of a galvanometer, either current sensitivity or voltage sensitivity, depends. We can discuss. So in this particular video, this much only. Thank you. आप वीडियोस को कंटिन्यूसली वॉच करिए एक एक करके, वन बाय वन, तो यू विल बी एबल टू अंडरस्टैंड एवरीथिंग स्टार्टिंग फ्रॉम द फर्स्ट वीडियो. थैंक यू.